Problem 10. Problem 10 off of 7-3 packet. You don't even really need to know this, but anytime you have a square and you draw in a diagonal, what kind of triangles are formed? Right triangles, but they're a special kind of right.
90, 30, 60,
45, 45, 90. 45, 45, 90. Again, I'm going to show you something here in a second because they just tried to trick you on this problem. This is a 45, 45, 90 triangle. You've got to remember how to label it. The 45, 45, 90 triangles, 30, 60, 90 triangles, and the trig ratio triangles, first thing you got to do every single time, label them. All right? In a 45, 45, 90 triangle, the sides across from the 45-degree angles should be labeled what? Don't put opposite. That's for the trig ones. Look in your notes.
What is it? Is it
L. This side over here. L. Both the 45s. If the angles are the same, the sides should be labeled the same. What's the side across from the right angles? What should it be labeled? L radical 2. Is everybody that lost on that?
Wait, where did this came from my paper?
You're on the wrong kind of triangle. So that's a 45, 45, 90 triangle. What Caitlin's looking at is a 30, 60, 90. Let's go over it real quick to make sure you remember it. In a 30, 60, 90 triangle, the side across from the 30-degree angle is always labeled what? L. Side across from the 60-degree angle, L radical 3. Side across from the right angle, 2L. Every single time you see one of those two kinds of triangles, that's the way you got to label them. Does everybody sort of understand that now? You got to label them that way. So if I gave you a triangle, told you it was a 45, 45, 90 triangle, I told you this side was 7, those sides should be labeled L and L, this side L radical 2. This doesn't have anything really to do with the problem here, but sort of same idea. You set up an equation from that. So what do we know L is going to equal? L equals 7, right? So how long is this side? 7. How long is this side? 7 radical 2. Don't make those harder than they are. On this one, they tell us the perimeter of this triangle is 30, and they want us to find that side right there. Do I even need to know the L, L, and L radical 2 thing? All you do is take the perimeter and divide it by 4. So grab your calculator. What's 30 divided by 4? 7.5. That's your answer to number 10. You didn't have to use any of the other stuff. Just had to take the perimeter and divide it by 4. Now you would have to use it to find this side. If this side's 7.5, knowing what you know about 45, 45, 90 triangles, what's this side going to be?
7 radical 2.
Close.
Or
7.5 times radical 2. What if I give you another square? And I tell you that this side is 6. Anybody tell me how long that diagonal is going to be?
6 radical.
Just 6 radical 2. Give you another square. The 7.5 was because that side was 7.5. I give you another square. Drawing the diagonal, I tell you this side over here is 3. What's this diagonal? 3 radical 2. Draw another square. I tell you the side over here is 12. Diagonal is 12 radical 2. Let's see if I can confuse you here. I give you this square. I tell you the diagonal is 14 radical 2. What's the length of the side over here? I can't confuse you guys. Right? So every 45, 45, 90 triangle, instead of going through and using Pythagorean's theorem or the trig functions or any of those things, it's always that way. It always has that pattern. Every single time. All right? Now, could you have went through here and used the trig ratios to find one of these sides? Yeah, you could have. It'd just take a little longer. All right? So it's probably easier to use the patterns. In a 30, 60, 90 triangle, again, different labeling. Side across from the 30-degree angles, always labeled L. Side, where did I come up with L from?
Length is random.
Just random. It's a variable. It means absolutely nothing. The only reason I use it, the book uses this. If you look in the book, and they have a 45, 45, 90 triangle, they label it this way. X, X, X radical 2.
I like that better.
Is that any different than the way I have it labeled? No, it's just a different variable. I use L because usually when they stick when they stick a variable in there that you're trying to find, what variable do they always use? X. And as soon as we stick an X in here, where you got to label it, and then they already had an X in there, is that going to be confusing? Yeah, extremely.
So we can use any letter though?
You could use any letter. Yeah, so Travis, if you want to use T's to stand for your name,
No, I'm thinking of plus.
T, 2T, T times radical 3, doesn't make any difference.
Maybe, yeah.
Number 6. What kind of triangle is number 6 going to form? 45, 45, 90. That's the same as the one we did. Do you want me to do that one, or do you want to pick a 30, 60, 90 one?
30, 60,
So pick me one.
5.
Number 5. Problem 5. If I draw an equilateral triangle, this is another thing. The last one dealt with squares. If I draw an equilateral triangle, what's this angle right here?
30.
60. What's this angle?
60.
60. What's this angle up here?
60.
60. Equilateral triangle, all the angles are the same also, right? If I draw in this, if I could ever hit the right spot, and form a right angle, what's that line called, or that segment called? It's got a special name that's going to be on the next vocab test when we take it. An altitude, right? Because it goes from vertex of a triangle to the opposite side and forms what? Right angles. That's an altitude. Well, when I draw in that altitude, this angle's 90, this angle's 60. What's this angle up here?
30.
30. What kind of triangle do we have on that side?
30, 60, 90.
30, 60, 90. How about on that side?
Same.
Same thing. So anytime you have an equilateral triangle, if they tell you it's an equilateral triangle and you draw in an altitude, you're going to have two 30, 60, 90 triangles formed. Well, in that 30, 60, 90 triangle, the side across from the 30-degree angle should be labeled what? What did we say on that last?
Oh,
L. Side across from the 60. I'm not going to feel any pity for you guys. We might take the test today. L. L radical 3. Side across from the right angle. Get your notes out from when we did 30, 60, 90, and 45, 45, 90. Have them laying there if you don't remember. 30, 60, 90. Across from the right angle.
And what is, that's the,
Yep.
How'd you get radical 3?
That's just the form. Anytime you have a 30... Yes. Yes. All right. Brooke,
I know, it cracks me up.
on the first page. Everybody listen. So we have an equilateral triangle, because I'm going to go through it quick, try to get through it before they start something else silly. We know they want to know this. They want to know this side. They tell us this side's 16. They tell us this angle's 60. This angle's 90. If that angle's 90, what's this angle over here? 90. What's this angle up here? 30. So we have a 30, 60, 90 triangle. In that 30, 60, 90 triangle, Mine's not drawn real well. Side across from the 30-degree angle, we just got done saying should be labeled what? L. Side across from the 60-degree angle.
L right, L three.
So let's go.
Problem.
On this problem, side across from the 30-degree angle is L, side across from the 60-degree angle, L radical 3. Side across from the right angle should be labeled what? 2L. Which one of those did they tell us? The 2L. So this is 16. Again, Kyle was saying, well, I don't have to set up an equation there, and that's fine if you don't have to, but you got to make sure you're not making careless mistakes. I always circle it and set up my equation.
Is the altitude y?
Yeah.
Alright.
So this side, we labeled 2L. They told us it was 16. How do I solve to figure out what L stands for this time? Divide by 2. What's L stand for? 8. So how long is this side down here that they labeled X? 8. How long is this side that they labeled Y, the altitude?
I don't know.
Yeah, you do.
It's 8.
Is it just 8?
8 radical.
8 radical 3. Don't let that radical confuse you. All you're going to do, replace that L with whatever L equals, which in this case happens to be 8. So you stick that in there. So that's your answers.
Last one to leave and first one back. How does that happen?
Dealing with 30, 60, 90, 45, 45, 90. Because when I look at number 3 on the bottom, is there a 30-degree angle or a 60-degree angle or a 45-degree angle in that? No. As a matter of fact, what is the angle? Third page.
Problem 1.
Oh, problem 1, 49. Sorry, I'm looking at problem 3. I don't know why I was. So 49 degrees. Well, that doesn't fit one of those other 2 kinds that we did. So when you do that, you got to use your trig ratios. And on your trig ratios, the main thing to remember, SOHCAHTOA. SOHCAHTOA. What's the S stand for? Sine. What's the C stand for? Cosine. What's the T stand for? Tangent. And then these other parts tell you what the ratio is. What over what. Every single time you do one of these problems. Again, this is number 1 on the 3rd page of the packet. I'm just going to draw the triangle. I ain't drawing the mountain or whatever it is that they got standing there. I would highly suggest, too, when you draw pictures like this on the test, do I really want to see some big elaborate picture? I might put,
49.
oh, sorry. I might write something on there and put nice, and then put a -3 on there because you drew a real nice picture but didn't do the math anywhere close to correct. All right? Last test, who was it? Oh, it was Hannah here, drew me, or maybe that was a worksheet, drew me that nice giraffe. That's great.
Did you really?
Pretty picture.
Wow.
Pretty picture. Does it help her do the math? No. So on this, first thing you're going to do every single time you get this triangle, just like with the other triangles, you got to label it. But your labels are different now. So if you don't know these labels, you might want to add it to the other ones. You might maybe title it trig. When you're doing the trig ratios, you pick out which angle you're going to deal with. How do we know which angle to deal with here? The only angle that they told us, right? They told us the 90, but I told you you're never ever going to use that one. So which, am I going to use this angle? No. I'm going to use the one that they told us. Or maybe the one that we're looking for. Side across from the 49-degree angles. Anybody remember what that's supposed to be labeled? The opposite leg. Side across from the right angle is supposed to be labeled what? And then the other side's always labeled the adjacent leg. What's adjacent mean again? Hooked to, attached, right next to, whatever.
The hypotenuse is always the biggest side, right?
Right, and it's always across from the right angle. That's why I draw the arrows in. This is the opposite side because it's opposite the angle that we care about. This other side, the one that's sort of the oddball, it's not the hypotenuse, it's not the opposite, it's the adjacent side, or the adjacent leg. Which one don't we care about in this picture? We don't care anything about the hypotenuse. We want to find the opposite leg. We know the adjacent leg. The hypotenuse, they didn't ask us to find it. They didn't tell us what it was, so we just don't care about it and we get rid of it. And this is where most of you are going to have trouble at, because nobody knows whether you use sine, cosine, or tangent. Well, the way you decide which one you use is by the information that you're using. Looking up here, which one deals with opposite and adjacent? Tangent. So every single time you're going to write this, this is what you're going to do. You're going to put down your trig ratio, not what I'm writing right now, this is just an idea. Then your angle comes next, then your equal sign, then your fraction. Every single one of these equations is going to be written out this way, and you're just going to fill it in. So for the trig, for the ratio, which one did you guys just tell me? Tangent. What's the angle that we're dealing with this time? So we write 49 right there. Equals, then we write our ratio. Well, tangent is what over what? Very good. Opposite over adjacent. So what is it? X over 400. I'll stop for a second. Does everybody understand that? Once you have that equation, what I want you to do, and this isn't something that's necessary, but I think it's the easiest way to teach you how to do it. Put a 1 underneath that tangent of 49. Now, if it's the tangent of x, if you're looking for the angle, then you don't do it this way. This is the way we do it if you're looking for one of the sides of the triangle. How come I put a 1 underneath there? What's it make this look like? A proportion. Next thing I do, I can't cross multiply here because I don't have any idea what t times 400 is, or a times 400, or n times 400. That doesn't make any sense. So next thing you do is you get rid of that silly word there. And you do that by grabbing your calculator, and I'm not grabbing the calculator, so I'm hoping that the rest of you are grabbing it so that if somebody tells us the wrong answer, you don't all look stupid and write down the wrong answer. And you punch in, you don't hit second, you just hit tangent 49. If you have one of the calculators that's backwards, then you hit 49, then the tangent button. Somebody tell me what is the tangent of 49-degree angle?
1.150.
Give me one more number.
3.
3? Does anybody agree, disagree with Kyle? Round the 3 up to what?
4.
4?
I guess you could, because the next number's a 6.
Next one's a 6, so round it up to 4. That'll work. Now, if you forget to do that, is it going to make a big difference in your answer? No, that's why we go out so far, because now you're out 10,000ths of a number. Now, it's going to make a little bit of difference, but not a whole lot. Anybody not get this? Tell me now if you didn't get it. I'm not going to yell at you. I just want to know so that I can fix your calculator.
Good. Wait, I just don't understand when you hit second and then
That's when we're looking for an angle. So when we know the angle, when you put a number right here by that word, you don't hit second. When you write it, when it's something like this, tangent of x, that's when you hit second, because you're looking for the angle this time. Okay? Does that make sense, Brianna?
yeah.
Over here, still got x over 400. We cross multiply. I'll do the hard part for you. 1 times x is x. Somebody do the easy stuff for me.
460.1473.
Slow down. 460 point,
1473.
we'll say 0.1. Since we're finding the side, we don't want to go out a whole bunch of places. All right, just go out 1 or 2 places. That's plenty. If you're finding an angle, round it off to the nearest degree, nearest whole number. If you're actually finding the tangent, cosine, or sine, then you always want to go out 4 places. All right? So how long is this side right here in this triangle? 460.1. Whenever you get an answer, make sure it makes sense. This side over here was 400. Does it make sense for that one to be 460?
Yeah.
Yeah. Give me a number that would fit in over here for the hypotenuse.
480.
Anything higher than 460, right? Because it's got to be the biggest. So you could always... Now, what if you came up, Mrs. Fagan come up and asked me the other day because she was getting crazy answers when she was helping somebody. had a problem like this, and this side over here came up to be something like 5,000.3.
No,
Is that going to work?
it could.
No. Now, could it? Remember, we had a rule earlier this year that said any two sides of a triangle must add up to be more than the third side. Well, is 400 plus 460 bigger than that? So that won't work. So make sure your answer makes sense for the problem. All right?
Yeah.
Again, just like the problems where we were doing the shadow problems before, and you were trying to figure out Sally's height, and if you came up with Sally was 60 feet tall, well, that was probably not a good answer. There's probably something wrong there. All right? What's your question, Emma? Number 8 on the last page. You just wanted to hear me say your name, didn't you?
You didn't say my name.
It's on the paper.
Oh, is it? Couldn't if you want to. That's fine.
Joe is at the end of the pier, 30 feet above the ocean. His eye level, I'm just kidding you, Kyle, that's Kyle, is 3 feet above the pier. He is using binoculars to watch a whale surface. If the angle of depression of the whale is 20 degrees, how far is the whale from Kyle's binoculars around your answer to the nearest foot? If they draw you a picture, and this confuses you when you read it, like everything that I ever read confuses me, all right, because I'm a terrible reader. That little short paragraph there, I'd have to read 4 times to make sure I understood it, all right? So if you get confused, I hope none of you get confused as easy as me when you're reading. And they draw the picture for you. Do you even need that rest of that problem, or to read all those words? So they give us this. Now, I'm not drawing the water and the whale out there. This angle right here is 20 degrees. Guy standing here, this is 3 feet. From here down is 30 feet. And they want to know the angle of depression is how far is the whale from Kyle's binoculars. So they want to know this distance right here. Well, the bad thing, let's do this first. How long is this side? 33 feet. You had to add those two together to get the whole thing, right? So 33 feet. This is going to be our x because we don't know it. That's how far the whale is from him. Now, we need to know, other than the right angle, we need to know some other angle in here. This is his angle of depression. The whale's down here and it's looking up at him, hoping he falls in the water so he can eat him. What's the whale's angle of elevation? What do you know about these two angles right here? They're alternate interior angles and they have to be congruent. So if that's 20, what's this? That helps us because now we have an angle. Which angle are we going to deal with in this triangle? Do we want to deal with this one? That one right there, right? Because that's the one we know. How am I going to label this triangle? What's that going to be labeled? Opposite leg, good. Side across from the right angle is going to be labeled hypotenuse. Every single time you got to go through and label this triangle. What's this other side going to be called? Adjacent. Do we care about the adjacent this time? So get rid of it. Decide which trig ratio you're going to use. I erased the SOHCAHTOA up here, but hopefully you can remember it. Which trig ratio deals with those two parts?
Sine.
Sine. The SO part, right? Sine deals with opposite and hypotenuse, and that's the two we're dealing with. So we write out our thing. Sine, what goes after the sine, cosine, or tangent? 20, the angle always, equals, then we do our fraction every single time. Trig ratio, angle, fraction. How are we going to write the fraction this time? Which one is on top, 33 or x? Because opposite over hypotenuse, right? So 33 over x. Put a 1 underneath that. What's the next thing I do? Rewrite it. finding what? So grab your calculator, don't hit second, because we're not looking for an angle, we know the angle, and you hit sine of 20 degrees. Now, before anybody says anything, I told you that the sine and cosine should always be less than what? 1. So if you come up with something like 2.3578, whatever, your calculator's messing up, and I need to know that, all right? It's got to be something, point something, 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 something. What is it?
3420.
Everybody agree with that?
Yeah.
Anybody not agree with it? Make sure you tell me if you're not getting that on your calculator, because I'm not going to yell at you. I just want to make sure that your calculator's doing the right thing. Now what do we do? Cross multiply. I'm going to do the hard part for you. 1 times 33 is 33. What's the other side? Now watch, because everybody's letting this confuse them. If I wrote this up here, 3x equals 33, what would you do next? Divide by 3. You divide by the number that's with the x, right? What do you do down here then?
Divide by 3. 420.
Divide by that big long decimal. Before anybody hollers out an answer, what should happen to a number when you divide by something like 0.3?
Shouldn't get bigger.
It should get bigger.
Yeah.
Before I ever grab my calculator to do this, some of you, and some of you this won't help, and that's fine. Just don't listen to me right now. But I know 0.3 is about a third, right? That's somewhere close to a third. So I look at this and I say, my number should get bigger by 3 times, because that's 1/3. Well, I know that the answer should be somewhere around 99, right? So if I come up with 600, I know I messed up somewhere. If I come up with 50, I know I messed up somewhere. What is 33 divided by that?
96.49.
I'll just say 96.4. Is that pretty close to 99?
Yeah.
That was a pretty good guess on my part, right?
I want us to round up to 5. The next number to 100.
Yeah, maybe.
Is that what we were
96.5.
supposed to find?
Yeah, 96.5.
Is that what we were supposed to find?
Yeah.
Yep, that was x. That was the hypotenuse right here. So his binoculars are 96, about 96 and a half feet from the whale. He's only 96 and a half feet from the whale. I'm not sure why he's using binoculars. I'd probably be scooting back a little bit. I wouldn't want to be quite that close.
Can we do something on 375?
375?
Yeah, because earlier you didn't show me how to do the one on the outside.
Pick one.
Remember one, you didn't show me that one. You showed me the second one.
That was the same thing we just got done doing. They're all the same. What's the first thing I do? Label it. We're going to deal with this angle. What's that side going to be labeled? Opposite. Side across from the right angle. Hypotenuse. The other side. Adjacent. So that's first thing. Second thing you do is set up your equation. We got to decide which trig ratio we're using. Which one do we? Which sides do we care about? Opposite and adjacent. Which trig ratio deals with those? Tangent. So we say tangent. What goes right after the word? Our angle, which is 28, equals something over something. X over 32. What do I do next?
Over 1.
Put a 1 underneath that. Then what?
Tangent 20 is...
Take your calculator, figure out what the tangent 28 is. I know all of you don't need the calculator because you memorized that chart I gave you, right? What is it? 5317. Everybody agree with that? Now what do I do? Cross multiply. 1 times x is just x. I'll do that part for you. What's the other part gives?
Oh, the answer?
Uh-huh.
17.014. Was that right? Because I had it right the first time.
So we'll just say we'll round it off to about 17.0. They didn't give us any units, did they? So that's our answer. How come I put the .0? Is that necessary? Why is it necessary?
Because it's similar.
It's more accurate. Remember when you did sig figs in science class? And if I just wrote down this number, 17, then the next person that looks at that thinks I rounded it off to the nearest whole number, right? So they're thinking, all right, Mr. Ebersol wrote 17, but we know he's never very precise. So the answer could actually be, remember when we did precision back at the start of the year? The answer could actually be anywhere from 16.5 to 17.5. So that's a pretty wide range. Well, when I put that 0 on there, now they look at it and they say, oh, Lavender did this problem. She's pretty accurate. So we know that it's between 17.1 on the high end and 16.9 on the low end. Is that a lot more accurate than me just writing 17? So that's a significant figure even though it's a 0. I know most math teachers have always told you, well, don't put that 0 on there, it's unnecessary. Well, it is sort of necessary because it tells you how accurate you are. If we even went out another place, then that's telling everybody that we're even being more accurate. But we probably won't get a couple problems done if everybody keeps talking. So what I want to do, pick a worksheet and tell me a problem to do off of that worksheet.
This one.
I got a left hand, I got a right hand.
The right hand.
The right hand, which number?
What's the hardest one?
Number 0 is the hardest.
Number 2.
Number 2, using trig ratio to find the value of x. As I'm writing this up here, this is number 2 off of this worksheet. I would highly suggest that you're writing it down as I'm doing it. As I'm writing it up here, first of all, my triangle looks terrible. Some of the problems say solve the triangle. When they want you to solve the triangle,
Supposed to be a 90-degree angle.
yeah, sorry. When they want you to solve the triangle, you got to find all the angles and all the sides. So if I was going to solve this triangle, could I find that angle right there real quick?
Yeah.
What do you know about these two angles? They add up to 90. So this would be 21, right? So if they ask you to find their solvent, then you can find that by 3 angles of a triangle must add up to be 180. This one didn't ask you to do that. That's our angle. Side across from that angle should be labeled what? The opposite. Don't look at my triangle because it's terrible. Side across from the right angle should be labeled what? Hypotenuse. The other side is the adjacent. Which trig ratio are we dealing with this time? Opposite and adjacent is which one? Tangent. So we do the tangent. What goes next? 69 equals what over what? 25 over x. Opposite over adjacent. Put a 1 underneath that. Somebody help me out. You should be ahead of me. What's tangent 69 degrees?
Good afternoon, everybody. Couple afternoon announcements. Chris Scott, please come to the high school office. Also, good luck
Nobody knows what
tonight to our
tangent is?
baseball and our softball team as they will travel to Newton for 5 o'clock games for both, so good luck to both teams. And those are all the announcements we have for today. Everybody have a great rest of your afternoon. We'll see you back here tomorrow. Thanks a lot.
Close enough. Not going to go out any farther than that because we're running out of time.
I like.
Watch. We cross multiply. You get 2.605. X equals 25. Now what do we do? Divide by 2.605. Somebody help me out. What's 25 divided by that?
9.596.
So 9.6 we'll say. That's supposed to be a 6. Does it make sense for that to be 9.6?
Yeah.
The packet.